Oh, hi. This video is about looking at a collision between two objects. And so in each and every collision, total momentum of the system is conserved, provided there are no external forces. And the second point is that change in momentum of one object is equal and opposite to the change in momentum of the other object. And also during the collision, center of mass of the system keeps moving with the same constant velocity. For all of these conditions, there should be no external forces. So now we're going to look at some collisions. So if you look at this question, so blue ball was moving in this direction and it collides with the stationary green ball, and after the collision, two balls move in this direction as shown here in the diagram. What we are asked in this question is that what will be the speed and direction of the blue ball. Roughly the direction is given, but we are asked to find out the exact angle and the size of the velocity, whereas we are given the velocity and direction of this one. So first of all, to calculate the momentum of any object, we use the formula P equals m times v. So we will draw a momentum of the system before the collision, which will be only due to the momentum of this blue ball because the green ball was stationary. Now, since according to the law of conservation of momentum, total momentum of the system after the collision will be same as the one before. So we'll draw an equal size vector. And now we've been given, in this question, we are given the momentum of the green ball. So we'll draw a vector over here. And by completing this one, this was not given, but we were given this one and that one. So we need to draw a vector here, and that will be the momentum of the blue ball. So that means blue ball goes roughly in this direction. Then using Pythagoras and the tens, we can find out the size of the momentum of this blue ball and also the speed, because P equals mv. So that's how we solve these type of questions using the law of conservation of momentum. Now, second question we are going to look at is from the point of view of velocity of the center of mass. In this question, a white ball moves towards the black ball. Black ball is a little bit bigger in size as given in the information. And then after the collision, the two balls move in two different directions. So what we know is that initially, the center of mass, which was not exactly in the center, but more towards the black ball, it was here. And since this ball was moving, that means center of mass will also be moving. So we can use a formula to calculate the initial position of the center of mass by using a formula m1 d1 equals m2 d2. And then this center of mass is moving. To find the velocity of the center of mass, we use this formula. Velocity of the center of mass is m1 v1 plus m2 v2 divided by the total mass. So what we know is that center of mass, that was the velocity of the center of mass before the collision. This one shows the position of the center of mass every second. So that's where the collision happens. So 1 second after the collision, it will have the same velocity. So it would have moved the same distance as it moved here. So that's the velocity. So this vector from here to there shows the velocity of center of mass after the collision. So if we know this velocity, then we can calculate this velocity and that velocity by using geometry, which is done in this question. Third thing, we will look at is from the collision, but from the point of view of change in momentum. So in this question, red ball was moving, the blue ball was stationary, and after the collisions, two balls go as in this direction as shown. So, the momentum of the blue ball changes because there was a force acting when this ball hits the blue ball. So change in momentum happens because whenever there is an unbalanced force. The momentum of the red ball also changes because blue ball was applying a force on this one. And according to Newton's third law, action and reaction forces are equal. So both balls will experience the same force, but in the opposite direction. And now we are going to look at the change in momentum of the red ball first. So red ball final momentum is in that direction, which is shown by this vector over here. Initial momentum was in this direction, so we draw to find the change in momentum, we do final momentum minus the initial momentum. We've already calculated the values of the momentum here. So then this vector over here gives us the change in momentum of the red ball. And we can use Pythagoras and geometry to find the size of the momentum. Now, if you look at the blue ball was initially stationary, and then after the collision, it moves in that direction. So change in momentum of the blue ball will be in that direction. And that is shown by this vector over here. So if we compare these two, this is the change in momentum of the blue ball. This is the change in momentum of the red ball. And if we look at the values, they're equal in size. This one is equal to that, and they're opposite in direction. And so if they're opposite in direction, then forces must be also equal and opposite in direction. And if we want to calculate the force, then we use the formula impulse equals force times time, and gives us the direction of the force. That was only the force on the blue ball. So that's how we look at the change in momentum in a collision. So that's all for this video.